Hi, we want to solve for x in x raised to the power square root of x equals 2. So let's say solution. Do you know that this question actually stumble even alpha student? Alright, let's look at it together. So let's know that if you have x, this is equals to square root of x square, right? Because this square will cancel this square root, right? So now here, let's our x be equals to square root of x square in this equation. So we will have square root of x square, right? So we can put it like this. So then we have square root of x equals 2, right? So which means that we have square root of x square times what number which is raised to a certain power is again raised to another power. The powers are multiplied. We have 2 times square root of x equals 2. So from here, we let our square root of x be, let's say m. Let square root of x equals m, right? So we have square root of x here, we have m square, right? Multiply by m. This equals 2, all right? So here we will have m, 2 times m, we have 2m equals 2. So from here we introduce ln to both sides. So we have ln m raised to power 2m equals ln 2. So then let's remember that from this law, if you have ln a raised to power b, this will be equals b ln a, right? So applying this to this, we have 2m will come forward here. Then we have ln m equals ln 2, right? So here we can divide both sides by 2, right? So we know these two, we cancel these two. So we will have m ln m equals ln 2 divided by 2, right? So here, let's recall that if you have exponential ln m, this will be equals to what? This will be equals to m because exponential cancel ln, all right? So now we will have m here, so that means that we can replace this with this. We replace m with this exponential ln m, so we have exponential ln m, right, multiply by, so we have ln m here, ln m equals ln 2 divided by 2. So now let's recall that the rampant function of x, exponential x, is equal to what? Is equal to x, right? So the denominator here and the power, if the same, so we are going to have our unknown there, or whatever is there. So now if you introduce the rampant function to both sides of here, so we will have the rampant function of exponential ln m multiplied by ln m, right, equals the rampant function of ln 2 divided by 2. So now, this and this can be the same, so we can rewrite this as the rampant function of ln m multiplied by exponential ln m, right, equals the rampant function of ln 2 divided by 2, all right? So from this that I said, so we will have this becomes what? Since this and this the same, we have the rampant function of this will becomes ln m equals the rampant function of ln 2 divided by 2, right? So look at here, we want to obtain our hem, so we have a lane here. To cancel this lane, we introduce exponent to both sides. So we'll have exponential lane m, right, equals exponential the rampant function of lane 2 divided by 2. So what did I say? I said this exponential we can do this lane, right? So we will have m equals exponential of the rampant function of link 2 divided by 2, right? Guys, we are going to do something interesting here. So here we have to recall that if you have the rampant function of infinity exponential infinity, this will be equals to what? Like I said, denominator and power the same, we will have infinity. And this is equals the rampant function of infinity. So exponential the rampant function of infinity. This is what it means. So now if we take this, we consider this and this. So we'll have infinity equals the rampant function of infinity, right? Exponential the rampant function of infinity, right? So now since we want to obtain this, we can easily divide this by the rampant function of infinity, right? So and here the rampant function of infinity. All right, so we know this, we cancel this, so we have exponential the rampant function exponential sorry the rampant function of infinity equals infinity divided by, we have infinity divided by the rampant function of infinity. So therefore if we cross multiply and make the infinity the separate formula, we will have, applying this to what we got above here, right? So we will have infinity becomes our link 2 divided by 2. So just by comparing, do you get? So you can note this equation. So if you substitute m equals ln 2 divided by 2, then divided by the rampant function of ln 2 divided by 2, right? So we are going to have m equals ln 2, right, divided by, if you change this division to times, so we have 2 multiply this, so we have 2 the rampant function of ln 2 divided by 2. So now we have m equals square root of x, so which implies that our x equals m squared. Do you remember this? Where we said from the beginning, so like we have let our square root of x be m, and this is what it implies. So now by substituting this, so we have our x, I will have our m replaced with x, right? So we have x, right? So equals ln, this is the general expression we are working with, right? So we have x, right, m squared. So this is m, so we have to square this to get our x. So we have ln 2 divided by 2 rampant function of ln 2 divided by 2, this square, right? So now if we use Wolfram table, we are going to obtain a numerical value for this x. So this you can consider this as your final step. So but if you use the table, you are going to get the numerical value for this. Thank you for watching, guys. I hope you enjoyed this video. Kindly like and leave a comment, and don't forget to share with your friends and network. Do also subscribe to my channel to stay updated on my next video. Bye.